Hey fellas, welcome to Oda class. I am Prince and I am going to teach you something very amazing today. It's distillation. So, let's see what is this distillation in today's class. But before that, let me introduce you to the most innovative edtech company in India right now. And the proof of it is from the most amazing survey company of India from Times Group. You can see that we have got these amazing awards from the Times Group. Now, I am going to introduce you to our Briz course. Now, you will say, so you are talking so much about Oda class. How is this Oda class so good? So, I'm not telling anything which you don't want to believe. I'm telling you that you come to our platform and check it out for yourself. So, that's why I'm presenting to you this Briz course, which is going to start on the coming Monday. Now, in this Briz course, the duration is just of a week. Okay? Then you will be getting three math session here, three science sessions here. Apart from that, you will also get a personal teacher support. Day or night, anytime you have any doubts, you can text your mentor teachers, you can call your mentor teachers, and those mentor teachers are really your personal teachers. And they are going to give you every kind of support possible. Now, what more do we have? So, you can solve your homeworks on app, you can give your tests on app, and you can also get your books and PDF from the app itself. So this app is going to be your everything when it comes to studies. Moving on, here you see there is a link in the description box, and by pressing on this link you can join our course just for 29 rupees. So you can see the price here, it's just 29 rupees. So I will not fear saying this that our course price is lesser than that of a Cadbury chocolate. So, guys, I promise you this is going to be one of the most amazing experiences of your life. So, why not go for it just for the price of 29 rupees? Now, moving on. You say this guy, you say this guy, we are same. Now, here, I'm Prince and I'm your master teacher of chemistry. I have done my chemical engineering from NIT Calicut. I have overall 6+ years of teaching experience, and in these years, I have taught more than 60,000 students. So, this was about me. Moving on. Now, all of you already know that we are going to learn about distillation, right? So, what is this distillation? Why do we care about distillation? Why do we need to study this distillation? For God's sake, right? All these questions might be coming to your mind. So, let me tell you, distillation is just a separation technique. It's just a separation technique. Every morning, our day starts with a cup of tea. Now, when we make our tea, it's a very simple process to sieve it, right? There is a sieving device in which we put the tea leaves are separated, and we get our tea in our cup, right? Same way, distillation also separates something. Now, the principle behind distillation is based upon boiling point. Here we can separate different liquids. Right? I hope you're understanding it that we are separating different liquids. Okay, it's all about liquids here when we are talking about distillation. Of course, there can be solid components, but we don't want those components. We want to extract liquid, and that's why we use distillation. Moving on, now, what are the applications of this distillation? You see, the first application here is this oil and gas industry. You know, many people say that oil and gas is the problem behind all the problems, right? All the wars are fought because of oil and gas. But do you know, guys, that without distillation, we would not be able to convert crude petroleum into petrol, diesel, gas, right? So distillation is the major culprit here. I would fear saying that because If we did not know about distillation, this crude oil would be just mud to us, right? Moving on, in the recent pandemic, we got to know the importance of medicines, vitamins, right? So these medicines are also manufactured with the help of distillation. So we can be thankful to the process here. Then food and beverage industry has been revolutionized due to distillation, due to the experiments we can do in a lab, and we can be sure that okay, this Maggie is not going to be harmful to our customers, this chocolate is not going to be harmful to our customers because we have checked it and checked it and checked it again, and it is safe for consumption. So there also distillation helps us. Then there are laboratory uses. So for all you young kids, how do you know things about distillation? How do you experiment about it? You do it in a laboratory. So we are thankful that we can do big stuff in small schools, right? And in Oda class as well, right? Moving on, 1 second. Okay. Now, what are the different types of distillation we have? We have simple distillation, fractional distillation, vacuum distillation, and steam distillation. Now, simple distillation and fractional distillation is the major thing we are going to cover today. We will keep vacuum distillation and steam distillation for some other day. Okay? So let's talk about it. Distillation is the process of selective boiling. Okay, so let me give you one example here. The example is really simple to understand. All of you will get it. Let's say we have alcohol and we have water. So we have a mixture like this. Okay, so what do we do with this mixture? We have to separate it. We want alcohol here, ironically. So here, when we want alcohol, what do we do? We selectively boil alcohol so that it converts into gas state. When this alcohol converts into gas state, we condense it. First, we try to boil the mixture. We get alcohol out as vapor, and this vapor again we condense, we cool it down, and then we are going to get this alcohol in a separate vessel, right? So this is how we conduct distillation. First we boil it, convert it into vapor, and then we get the liquid form in a separated vessel. I hope all of you are getting this. Now let's move forward. So guys, you see, there are some key terms you must know to understand distillation in a good manner. So I suppose you already know about condensation, but anyways, let me tell about it so that I am sure that you guys know. So it is a process in which a gas converts itself into liquid state, right? So here, gaseous state transitions into liquid states. Just that you have to learn. Moving on, then we have boiling point. What is boiling point? You have been learning it since you were a kid, that it is the temperature at which a liquid starts to convert itself into gaseous state very rapidly. And all of us have boiled a lot of water, frankly, during this COVID pandemic. I got COVID, and let me tell you, I used to boil water all the time. I used to cover myself as a bride. I used to have some hot pot in which I used to keep the boiling water, and I used to inhale a lot of steam to get rid of the infection in my lungs. So, guys, boiling is good, right? Sometimes it is good. Moving on. Now, let's talk about simple distillation. So, we have come to the topic. Here, simple distillation just separates two miscible substances or more miscible substances, right? So here what happens is you have two things mixed together, all right? Now you want one thing out of it. Let's suppose that, right? So out of two things, you want one thing. So what you will do, you will selectively boil it. When you selectively boil it, you will actually get it in the vapor form. And when you get it in the vapor form, you will condense it again. Hope that is clear with all of you. Now, what is a necessary condition for simple distillation? The necessary condition is this, that the boiling point difference should be really large. And I will tell you why we need a large boiling point difference. So, before telling you that, let's repeat the process which is happening here. First, we are having liquid. After getting this liquid, we are boiling it. When we are boiling it, it converts itself into vapor state, and then this vapor state is again transformed into liquid state. So this is a simple process. Now let me tell you, why do we need a large boiling point difference? See guys, we are heating two liquids here, right? Or let's say we are heating two things here. Let's say we have here salt plus water mixed together, right? And we are heating salt and water, right? So if the temperature is too high, then what can happen? Water can go into the vapor state, and salt will not go to the vapor state because its boiling point is really high. So let's suppose there is some liquid which has a very high boiling point. So let's call it A. So in this particular case, we say that A, if it is having lesser boiling point compared to water, so when we are heating the mixture, both A and water can go into the vapor state. So if both A and water go, right, then both A and water will be obtained here. And if we obtain both A and water here, what is the point of separation? We are not getting anything separated, right? So it's like you are keeping five bodyguards to prevent someone from coming to the party, and that person still enters your party, right? So you should not be doing that, right? So that's why I am saying that there should be a large boiling point difference here. Okay, between salt and water, there is a large boiling point difference. Water has boiling point of 100 degrees Celsius. Salt has boiling point always greater than 500 degrees Celsius. So there is a lot of boiling point difference, so that both salt and water do not come in this vessel. Otherwise, all our purpose is gone. Now, you will say, what is the use of this condenser, sir? So it's really simple. All of you cook something, right? Now, suppose you are cooking something in a pressure cooker, and that pressure cooker is really hot, but you are really hungry as well. So, when you are really hungry, how would you eat whatever you have cooked in your pressure cooker? You will cool it down by putting some water on it. What kind of water? Cool water, right? So same thing we are doing here. We are actually having this condenser through which cold water is passing. This cold water will cool down the vapor so that it condenses. You need to cool down the vapor so that it can condense into the liquid state. So it cools down, and then you are actually going to get hot water here. So this is cold water outlet, right? But here actually this outlet will actually give you little hotter water. It will still be cold, but the temperature will be higher here in the outlet because it has cooled down the vapor, so it has absorbed some heat. Hope that is clear with all of you. And here you get distilled water. I hope this is clear to all of you. Now, let me tell you, where do we use this simple distillation? We use this simple distillation in purification of tap water. Tap water, have a lot of heavy metals, ions. It can have acids and bases as well. So what we need to do here is we need to again follow the simple distillation process, and through that process we are going to get distilled water. And distilled water is called distilled water because of distillation. So I hope you knew that, and if you did not know that, then you can thank me, right? Then obtaining pure water from seawater. So when you are heating seawater, you are getting salt, common salt, which is left behind, right? For example, in this process, just here we learned that water will come out as distilled water. So what will be left behind? We will have salt left behind. So salt is also separated and we can use it, right? So here, what I'm saying is that you can obtain pure water from seawater. At the same time, you can get common salt also from seawater. I hope that is clear. Now it's time to learn about fractional distillation. the man of the moment, right? So again, when we are talking about fractional distillation, here no solids, no salts are involved. Here we are talking about just liquids. Two or more miscible liquids can be there, right? Now the necessary condition for fractional distillation is that very small boiling point difference should be there. I told you just now in the example of simple distillation that both salt and water should not be able to go up as vapors. Only one should go. But in the case of fractional distillation, both the components should be able to go up. Right? I hope all of you are understanding that. So, why do we want both the vapors to go up? We don't want that, but there are certain situations like that. And this fractional distillation is a separation technique especially designed for a situation like that. Okay, so that's why we say necessary condition is very small boiling point difference. The main components in fractional distillation are fractionating column, distillation flask, and condenser. Now, what is a fractionating column and why I'm emphasizing upon this fractionating column? Because this is the only difference between a simple distillation experimental setup and a fractional distillation experimental setup, right? In a fractionating column, we put some glass beads and all. We actually leave small gaps through which gases can pass, but the gases cannot pass just straight, right? Their path will become zigzag in nature. So let's see that. Let's observe that. See, this is a fractionating column. And if you can observe here, this fractionating column is the only difference between simple distillation and fractional distillation. And because of this fractionating column only, we are calling this fractional distillation, this process. Now, what does this fractionating column does? Let's see this now. Okay. So first of all, people, here you see we have two components, A and B. Right? Two components we have. Now let's say boiling point boiling point of A is lesser than boiling point of B. Okay? We are making this assumption here. Now, when we see this, if I ask you this question, that out of A and B, which one will be able to go into vapor state fastly? Of course, you will say A because A has lesser boiling point. It needs lesser time to go into the vapor state. So it can go into the vapor state very easily. All right. So here what will happen is when you start heating the mixture, first A will start to go because it can go rapidly, but at the same time, since the boiling point difference is very small, B will also say, I will not be left behind. I am not weaker than you. I will also follow you. So A is going forward, and like a police, B is also going forward, right? Now, here comes the magic of fractionating column. See, here the vapor cannot just go straight, right? The vapor must follow a different path. So the vapor will follow a path like this, zigzag, right? So instead of going normally up, it is going in a zigzag manner. So because of that, what will happen is A is having lesser boiling point. So it is more volatile, it is more energetic. So it will say, okay, I can go and reach here, this point. But B will be left behind because B does not have that much energy, right? So A will reach here, and when A will reach here, it will come here. Then again, the same thing will happen. The condenser will be there, and the vapor will be cooled down here, and here we will be able to get A, right? We will get A here, right? Why is B left behind? Because B does not have that much of kinetic energy. B does not have that much of kinetic energy to pass behind this barrier called fractionating distillation, fractionating column. Sorry. And also, guys, here in the fractionating column, at this portion, the temperature will actually be higher here. The temperature will actually be higher here, and the temperature will be lower here. Okay, so the temperature is going to be higher here. One second. One second, I will just correct it. Yeah. So the temperature is going to be high here, and the temperature will be going to be low here, because when the vapor is interacting here first, hitting here first, the temperature is higher for the vapor, so it will actually increase the temperature here, and by the point the vapor reaches here, the temperature will actually decrease, and that's why here low temperature you will find. Moving on. So it's simply like, you in simple distillation, what we do is displacement. The vapor directly goes up. But in the case of fractionating distillation, we are actually taking this long path for the vapor. Hope that is clear. And where do we use it? The most common use of fractional distillation of petroleum is in the distillation of crude oil, right, which we call petroleum. And here we get different components like, one second, here we get different components like petroleum gas, which is LPG, petrol, kerosene, diesel, fuel oil, and different kinds of residue material also we get. Moving on. So again, I welcome you all to the most innovative app in the country right now. And I welcome you all again to the Briz course, which has a 1 week period, and it has three maths and three science sessions. And it is going to provide you with personal teacher support as well. So whenever you have any doubts, you can actually call your mentor teachers, text your mentor teachers, and get them clarified. Moving on, so you can solve your homeworks on app, you can give your tests on app, and you can get your material on the app also. Now, you have the link in the description box. Just click on it, and the course is yours after you make the payment of just 29 rupees. And I will again remind you that your Cadbury chocolates are costlier than this. Moving on. So we like to incentivize our students, and you guys will definitely get a lot of coins in our sessions, and through those coins you can win these amazing gifts. So thank you so much. Goodbye.